Good morning. In this video tutorial, I will define Karnough mapping or K-map method for Boolean algebra or Boolean expression. What is Karnough mapping or Karnough map method? Maurice Karnough, a telecommunications engineer, developed the Karnough map at Bell Labs in 1953 while designing digital logic-based telephone switching circuits. Now, the Karnough map with the aid of Venn diagrams, let's put it to use. Karnough maps reduce logic functions more quickly and easily compared to Boolean algebra. By reduce, I mean to say reducing the number of gates and inputs. I like to simplify logic to a lowest cost form to save costs by elimination of components. Now, to define Karnough map, I want to say we can simplify Boolean functions by using Boolean postulates and theorems. It is a time-consuming process and we have to rewrite the simplified expressions after each step, right? To overcome this difficulty, Maurice Karnough introduced a method for simplification of Boolean functions in an easy way. This method is known as Karnough map method or shortly K-map method. It is a graphical method which consists of 2 to the power n cells for n variables. Here variables indicates the variables for Boolean expressions or Boolean algebra like capital X, Y, Z, capital A, B, C, etc. Now, the Karnough map is a graphical representation that provides a systematic method for simplifying the Boolean expressions. K-map method is most suitable for minimizing Boolean functions of 2 variables to 5 variables. We can take K method for more than 5 variables, but other methods like tabular method is far better than that of K-map method. So here I will discuss K-map method for 2 variables, 3 variables, 4 variables. But we can also do simplify Boolean expressions for more than 5, 6, 7, 8, etc. But it is my suggestion whenever you face more than 4 variables, you should use tabular method in place of K-map method. Now what is 2 variable K-map method? The number of cells is 2 variable K-map method is 2 to the power 2. This 2 means number of variables equals to 4. Now say x and y be 2 variables. So x here 0, 1, 0 means off position, 1 means on position. Here y represents 0 and 1. Now 0, 0, 0, 1, 1, 0, 1, 1. Or 0 means x complement, 1 means x, 0 means y complement, 1 means y. Then x complement, y complement, x complement, y, x, y complement, x, y. Or you can write 0, 1, 2, 3. This 0 can be written as m suffix 0 or m0, m1, m2, m3. In different ways we can express K-map method. By my suggestion is you have to stick with any one method, any one type. It will be better for practice. Now for 3 variable K-map method, the number of cells in 3 variable K-map is 2 to the power 3 because the number of variables is 3, that is equals to 8. Now this can be written as x, y, z. You can also write here x, y, here z. Then this will be like this is horizontal and that will be vertical. Okay. Now here x means 0, 1, yz means 0, 0, 0, 1, 1, 0 and 1, 1. See this one here, this one here. Okay. Now this is a trick to write down this 0, 1, then 2, then 3. Okay. Back to front 0 1, then 3, then 0 1 2, then 3, and see 4 5 6, then 7. And 0 means M0 or M0, M1, M3, M2, M4, M5, M7, M6. Actually, in the latter problems, I will use either this or this. For 4 variable K-map method, this is our variables A, B, C, D. Here the number of cells will be 2 to the power 4, that is 16. 16 cells, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, like this. Here CD is 0, 0, 0, 1, 1, 0, then 1, 1. Here also 0, 0, 0, 1, 1, 0, 1, 1. 0, 1, just jump to 3. Then 4, 5, 6, then 7. Then from here jump to the last row, that is 8, 9, 10, 11. Then third row 12, 13, 14, 15. So these are the techniques. To express the table for K-map method. Okay. Now, how can we minimize the Boolean expression or Boolean function by using K-map method? Actually, in practical life, we have to simplify circuits by the help of K-map method. It is very easy, up to 5 variables. So minimization of Boolean functions using Karnough maps. If we consider the combination of inputs for which the Boolean function is ones, 1 means on position, 0 means off position, then we will get the Boolean function which is in standard sum of product forms. Actually, in Boolean expression we have two forms: sum of product forms or min terms, and product of sum forms or max terms. First I will discuss about sum of product forms, that is min terms, and then I will discuss about product of sum forms or max terms. So these are the steps how we can simplify or reduce the Boolean expression by the help of K-map method. First, select the respective K-map based on the number of variables present in the Boolean function. If the Boolean function is given as sum of min terms form, means sum of product form, then place ones at respective min terms cell in the K-map. Actually, when I will discuss example on this, then you will get understand what is the meaning of these terms. Okay, just remember, if the Boolean function is given as sum of min terms or sum of products form, then place the ones at respective min terms cell in the K-map. If the Boolean function is given as sum of product form, then place the ones in all possible cells. I will not follow this second one because the second one is related to product of sum form. That is another way. Okay, we have to do later. First we do sum of product forms. So what is the concept? If the Boolean function is given as sum of min terms form, then place 1. Just stick with this number. 1 means on position at respective min terms cell. Check for the possibilities of grouping maximum number of adjacent ones. Means we first put ones in some cells, then we have to make groups of adjacent ones, and the number of ones should be in such a way that it may be 2 to the power 0 means 1, or 2 to the power 1 means 2, or 2 to the power 2 means 4, or 2 to the power 3 equals to 8, like this. Okay, means check for the possibilities of grouping maximum number of adjacent ones. It should be powers of 2, means highest power is equal to the number of variables considered in K-map, and least power is 0. Means whenever we make groups, we consider either 1 in a group, 1 1 in a group, or 2 1 in a group, or 4 1 in a group, or 8 1 in a group, or 16 1 in a group, or 2 to the power n ones in a group. The 2 to the power 1, it means the least number of ones should be 2 to the power 0, that is 1, and the maximum will be 2 to the power n, where n represents the number of variables present in the Boolean expression. After grouping, each grouping will give either a literal or one product term. It is known as prime implicant. What is prime implicant? I will tell you later. Just remember the word prime implicant. We have to use this word, or we have to use this concept in our practical approach. The prime implicant is said to be essential prime implicant. First, we have to find prime implicant, means we have to put ones in some cells, then we have to make groups. After grouping, we have to identify prime implements, and after identifying prime implements, we have to identify essential prime implicants. If at least single one is not covered with any other groupings, but only that grouping covers. This concept I will tell you later. Just remember prime implicant and essential prime implicant. Note down all the prime implicants and essential prime implicants. The simplified Boolean function contains all essential prime implicants and only the required prime implicants. Now, I am showing here few examples regarding grouping. See, adjacent cells which have ones can be grouped together in the power of 2, means only one can be make a group, that is known as single group. 2 square means 4 adjacent cells can be grouped. 2 to the power, oh sorry, I have not written here 2 to the power 1. There will be a 2 to the power 1, 2 to the power 0, then 2 to the power 1. That is 2 cells can be a grouped. That will be pair. Then 2 to the power 2, that will be quads. Okay, this is my mistake. This will be quads, and 2 to the power 3 8, that will be octants. So maximum power of 2 is less than equal number of variables in the Boolean expression, which I have already told. Now we already know what is min terms. Min terms means sum of product forms, and in the case of sum of product forms we put 1 or we use 1, and for max terms we use 0, which is product of sum forms. Sum of product form is represented by summation m. Here will be the expression small m, and this is our product summation, product sign capital M. Here will be the expression. Now groups do not include any cell containing a 0. This is very important. We cannot make a group with 0 and 1, but we can make 1 1 because here 2 ones present. Okay, groups cannot be diagonal. This cannot be do. Only we can do vertical or horizontal groups. Groups must contain 2 to the power 0, means 1 or 2 to the power 1. I have not written here again. Sorry, this is my mistake. I have to write 2 to the power 0 1, then 2 to the power 1 2, then 2 to the power 2 4, then 2 to the power 3 8, and so on. Okay, now see here I have considered 3 ones as a group, but I can take 1 1 1 1, means 4 ones as a group. So this is the wrong process, because we have to consider maximum number of ones, which should follow 2 to the power n rule, and that should be maximum. But here I can consider 1 1 1 1, means 4 ones we can consider, though I have considered here 3 ones. So I did not take here last one, so this is my mistake. So we cannot take this as a group, right? Next, each group should be as large as possible. See here again I can take this as a group 4 ones, and this as a group 1 2 3 4, 4 ones. Okay, now this is very important concept. Just remember, whenever you see my video, this tutorial, you just play and pause again and again, then only you can understand the whole concept, because Karnough mapping concept is quite lengthy. But after getting information and proper concept, you can easily solve any Boolean expressions and simplify them by the help of K method up to the number of variables 4 or 5, and over 4 and 5 I should suggest that you may use tabular method. If outputs are not defined for some combination of inputs, then those output values will be represented with don't care symbol. We can consider them as either 0 or 1. Actually, whenever we do problems of min terms, we put 1 for don't care symbol, and for max term problem we use 0 as don't care symbol. Now come to an example. Here the question is simplify the Boolean function f of w x y z equals to w x dash y dash plus w y plus w dash y z dash using K-map. So I have written here given f of w x y z equals to w x dash y dash plus w y plus w dash y z dash. Okay, you should use capital letters for representing Boolean variables. Now the number of Boolean variables is here 4, right? So 4 means 2 to the power 4, that is 16 cells will be here. The K-map is shown below, which I have already shown in my previous pages. Here this only you can write here C dash D dash, here A dash B dash. In this way I have written here, see 0 0 means Y dash Z dash. Either you write this or you write this, okay, any one, not both. Next 0 0 0 1, then 0 1, then jump 2 3 4 5, jump 6 7, then 8 9, jump 10 11, then come to the third row 12 13, jump 14 15. Okay, now I have put here some ones. How can I select the cells for putting ones? This is very important concept. Now see here, w x dash y dash, no z is present. So I can explain, or I can split this thing like this way. W x dash y dash is w x dash y dash into 1, that is w x dash y dash z plus z dash, because for Boolean algebra z plus z dash is 1 and z into z dash is 0. Now just multiplying w x dash y dash z, w x dash y dash z plus w x dash y dash z dash. Now come to the diagram. See w x dash is this, and y dash z is this. So just see they will intersect in this cell, right? That is R4, row 4 and column y dash z. Where y dash z? Here, column 2, right? Column 2, row 4 and column 2. So this is our row 4 and column 2. So I put here 1 in the intersection of row 4 and column 2. And w x dash here, w x dash row 4, and y dash z, y dash z dash, y dash z dash means column 1. The intersection is here 1. Okay, so 2 1 have been put it here. Next one is this wy. Wy can be splitted like this way, in this way. So the cells are R3 C3. See, this is our R3 and this is C3, means this one. Then R3 C4, R3 C4 means here. Then R4 C3, R4 C3 means here. Then R4 C4 means here. Okay, or you can just remember one thing, w x dash y dash. W x dash is present and only y dash is here. So just consider y dash this and y dash this, both are having y dash. So put here 1 1. Now see wy here, wy is here, wy is here. Now this is our w, and y is this one and this one. So w for this row and y means this columns, so 1 1. Next w dash yz dash, yz dash where, yz dash, this is our yz dash, means should be this column yz dash, and w dash means this two, right? So just taking intersection will be this and this 1 1. Okay, in this way also you can put ones. So this is our cells having 1. Now maximum number of adjacent one to form group is 2 to the power 4 equals to 16. Okay, means we can make groups having maximum 16 ones. But see the table. Okay, see the table, there doesn't exist any group having 16 ones. In fact, there doesn't exist any group having 8 ones. So we just come from maximum to minimum, means 2 to the power n, then 2 to the power n minus 1, then 2 to the power n minus 2 dot 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 2 to the power 0. So 2 to the power 4 16 ones doesn't exist. 2 to the power 3 8 ones does not exist. Then 2 to the power 2, 4 ones exist. This is one group, this is one group, and this 4 ones will make another group. We can consider grouping by overlapping. Okay, overlapping exists for grouping in K-map method. After doing 2 to the power 2, 4 ones for making a group, we then come to 2 to the power 1 means 2 ones to make a group, and then 2 to the power 0 means 1 ones to make a group. But if we see if we see carefully, we see there does not exist any one left or beyond the group, means all the ones are belonging to some groups. So the process is up to the mark. Now we get 3 prime implicants. The prime implicants means only single ones. Here this is one single one, single one, single one, single one, single one. But see, this one is having two groups. This one and this one are also belonging to two or more than two groups, but this one and this one only belong to this group, this one only belong to this box group, these two ones only belong to this column group. But this one belong to two groups, these two ones belongs to this one belongs to two groups, and this one belongs to more than two groups, means three groups. So you only consider single ones with only belong to one group. These are known as prime implicant, right? Now we have to find essential prime implicant. Okay, now what is the value of this? This is our M8, this is our M9, this is our M15, this is our M2, this is our M6. How can I know this? Come to the table again. See, this is our M8, right? This is our M9, this is our M2, this is our M6, and this is our M15. Okay, either you write this or you can write this, but you have to follow any one technique. So we got 3 prime implicants, wx dash, this is our wx dash, and this is our also wx dash, and this is our wy, this is our y z dash. Okay, now we got 3 prime implicants, wx dash, wy, yz dash. All these prime implicants are essential. Okay, these two ones, wx dash, this one, wy, and yz dash. Yz dash is this one, this is wy. Okay, this is our wy. So all these prime implicants are essential because two ones means M8 and M9 of row 4 are not covered by any other grouping. Only row 4 grouping covers those two ones, right? I said just before. Single one N15 means this one of square shape grouping is not covered by any other groupings. Two ones M2 and M6 of column 4 grouping are not covered by any other grouping. Hence, required simplified Boolean function is wx dash plus wy plus yz dash. Okay, so f of wxyz is wx dash plus wy plus yz dash, right? These two represent wx dash, this one represent wy, and this one represent yz dash. Just remember this, these are product and taking sum, this known as sum of product forms. So this is our simplified form of the given Boolean expression. This is the question, and this is our question, and this is our solution by the help of Karnough method. So this is our max term method. Next is this is our min term method. Now come to max term method. Follow these rules for simplifying K-maps in order to get standard product of sum methods. Now actually, while we face min terms problem we put ones, while we face max term problems we put zeros. and just follow the same process as we did for min terms problem. Same thing, but for min terms we put 1, for max term we put 0. So come to an example. Simplify the following Boolean function f of xyz, product of capital M 0, 1 to 0, 1 to 4 using K-map, Karnough map. This is more easy than before one, because the before one was given in expression form, but it is already given in values form. See, 0 means m naught, capital M naught, a1 means capital M1, 2 means capital M2, and 4 means m capital M4. So the given Boolean function is in product of max terms form. This is product and this is max term form. You can also convert this Boolean expression, the given one, this to this form, okay, or vice versa. Okay, same thing. Now the given Boolean function is in product of max term forms. It has 3 variables x, y, z. So we require 3 variable K-map. 3 variable K-map means 2 to the power 3, 8 cells, 1, 2, 3, 4, 5, 6, 7, 8, right? Now just write down x, y, z. Y, z is 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, 3, 2, 4, 5, 7, 6. Now see, it is already given 0, 1, 2, 4. So these are the cells. So just write down here 0 because this is max term problem. Then this is our second cell 1, 1. So write here 0. Then 2, where 2? This is our 2. So write here 0. Then 4. 4 is where? There 4. So write here 0. So as this is a max term problem, I have written here zeros. But if it is min term problem, I have to write here 1. Okay. Now there are no possibilities of grouping either 2 to the power 3. I said this earlier. We have to consider maximum to minimum way. Okay, here the number of variable is 3, so definitely 2 to the power 3, 8 zeros we have to consider. But see, we have exactly 1, 2, 3, 4 zeros, and this 2 zeros are adjacent, these 2 zeros are adjacent, and this is single zero. But I cannot say these 2 zeros are adjacent because we cannot consider diagonal zeros or diagonal ones. We have to consider either horizontal or we have to consider vertical. So these 2 zeros are adjacent, these 2 zeros are adjacent, and this is our single zero because there does not exist any zero neighbor to the cells of this zero, right? So here zeros are placed in the following cells M0, M1, M2, and M4. So we can make only this way. Whenever we do single cell group, we have to consider this open. Okay, this is our open. If it is written here, then we have to do it like this way. In this will be our open side. But if it is like this here, then open side will be this outer side way. So there are 3 possibilities of grouping 2 adjacent zeros. After these 3 grouping, then we have to come from bigger to smaller, means 2 to the power 3, 8 zeros, then 2 to the power 2, 4 zeros, which does not exist, and 2 to the power 1, that is 2 zeros, which does exist. Here 2 zeros this, 2 zeros this, means 2 group here. Then 2 to the power 2 to the power 0, 1 0, that is this single zero group. Okay, complete. So we got 3 prime implicants, where this is our prime implicant position because this 0 is only belonging to single group, this 0 only belonging to single group, and this 0 is definitely single group obviously, but this 0 does not belong to single group, it belongs to this column group and this or a row group, right? So we cannot consider this 0 as prime implicant. This is our prime implicant, this is our prime implicant, and this is our prime implicant. Now what is the value of this? The value is y plus z. The value is y plus z. This value is x plus y, and this value is z plus x. Okay. So we got 3 prime implicants, x plus y, comma y plus z, comma z plus x. How do you know this is the value of y plus z? The value of this prime implicant is y plus z. Just look here, y dash z dash. This is our column, right? Y dash z dash, and this is our what? This is our complement position, this is complement position. Just take whole complement, y dash z dash whole complement, that is y complement plus z complement, y complement whole complement plus z complement whole complement, and the result will be y plus z. Clear? Now come to this here. This is our row and this is our column, right? Here 0 is written, then we have to consider x dash and y dash, not z, because y dash is opposition, x dash is opposition. So x dash plus x dash into y dash whole complement, that will be x plus y. Now come here, here x dash is opposition, z dash is opposition, so neglect y, x dash z dash whole complement is x plus z. This is not actually proper way, but to remember the technique and to minimize the technique, you can do like this way. Okay, do you understand? If 1 is there, then we have to consider x, not complements. Here zeros are there, so we have to consider complements, not x. See, here 0 is present, so we consider here x complement and y complement, not z. So the result is x complement, y complement, then whole complement because of 0. Again here see y z complement. I did not consider here y, I have to consider here x dash. So the result is x dash z dash whole complement because of 0, and the result or output will be z plus x. Now these are sum forms, then we have to take product of them, that the result is max term. So this is our required simplified form of the given Boolean expression or Boolean function. So this is all about Karnough method. You have to do these two problems again and again, and after doing so, if you face any problems, you can do write in my comment box. I will help you later. Up to that, thank you.